Today we are going to talk about the importance of finite element analysis in tall buildings or any structural design process. Normally, when we want to analyze the behavior of a structure or a tall building, we need to create a mathematical model. Typically, pure mathematical models are governed by partial differential equations for continuums and solids. However, this is too complicated or complex for real structures and generally cannot be used except for very small and simple cases. For real structures, generally we use finite element analysis method. Finite element analysis method, in essence, is a numerical method to solve the partial differential equations. So it is based on the concept of discretization, which means that we divide the structure into small elements or mesh, as we call them. These elements or mesh are generally of four types: a point element or a point object, a line or a frame element or a frame object, then an area or a shell or a plate element, and finally a solid element or a solid object. So we can typically divide a structure in such a way that we can create a model composing of these four basic elements. And then when we put them together, then that structural model can be analyzed using the finite element analysis procedures. We also apply the appropriate loadings to this model. We apply the boundary conditions such as supports or fixed points. We can also include linear or nonlinear behavior in the model by modifying the properties. Essentially, we need to define the stiffness properties of the structure. We need to define the mass properties of the structure. We need to define the loading conditions, the boundary conditions, and any particular special cases of nonlinearity that we might want to consider. The finite element analysis is a very powerful tool which can be used to analyze a structure or even other objects of any problem or any other problems of any kind. It is used in geotechnical engineering, in sound engineering, even in biomedics for the design of prosthetics, and even the analysis of brain and heart motion. So finite element analysis is a very general procedure, but it is an essential tool for the designers of tall buildings and bridges or structures to create a model of their project or their structure before it can be built. Finite element analysis especially helps us to understand the dynamic properties or dynamic response of the structure. It helps us to understand the deformations that will happen. It gives us the insight into the response, such as stresses, strains, bending moment, shear, and so on, which can then be used to design the reinforcement or select the appropriate material so the structure will perform as we expect. So there are so many tools these days which are based on finite element analysis. Most of the time, the structural engineers or building engineers use tools such as ETABS, developed by CSI, or SAP 2000, also developed by the same company, or SAFE or NCSI Core. These are the most popular and common tools that people are using. Other tools also include STAD, which is a very popular software, especially in the recent past, and other programs that are coming up. What the engineers basically need to understand is that creating the right model is essential. That means the structure should be represented very well in the mathematical model or the finite element model, because the analysis is working on the model, not on the real structure. So it's safe to say that we are not analyzing the structure, but rather we are analyzing the model of the structure. So it's critical that we create the model properly, analyze the model properly, and understand the response and the importance of that response in the behavior of the building.